Need to nest your FastMCP server inside a complex routing structure while maintaining clean URL paths. You'll see how to mount a FastMCP ASGI app at multiple levels, first under inner, then under /outer, while ensuring the MCP endpoint remains accessible at /outer/inner/MCP. The pattern uses Starlette's mount to create layered routing without breaking the server's functionality. From FastMCP, import FastMCP. From Starlette, applications import Starlette. From Starlette, routing import mount. Hash create your FastMCP server. MCP equals FastMCP, my server. Hash create the ASGI app. MCP app equals MCP. HTTP app, path equals /MCP. Hash create nested application structure. Inner app equals Starlette, routes equals mount, /inner, app equals MCP app. App equals Starlette. Routes equals mount, /outer, app equals inner app. Lifespan equals MCP app, lifespan. This demonstrates the ASGI mounting pattern for composable web applications. The technique shows how to nest specialized services like FastMCP within broader web frameworks, creating a unified routing hierarchy while maintaining clean separation of concerns. What makes this distinctive is the ability to treat an entire RPC server as just another route in your application, rather than a standalone service. The pattern works by leveraging ASGI's mountable application protocol, where each component exposes its own routing tree. The outer application orchestrates traffic by delegating path prefixes to inner applications, with each layer handling only its designated routes. This creates a modular architecture where authentication, middleware, and routing concerns remain isolated, while still presenting a single cohesive API surface to clients. This approach solves the problem of service fragmentation in microservices architectures. You get the benefits of specialized servers like FastMCP for RPC operations, while maintaining a single deployment unit with shared infrastructure. It's particularly valuable when integrating AI tooling into existing web applications, or when you need to expose multiple protocol types, REST, RPC, WebSockets, under one domain. The trade-off is slightly more complex routing configuration, but the payoff is cleaner separation and easier maintenance. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tool servers. It handles the protocol translation between Python functions and AI model requests, managing serialization, validation, and execution. From Starlette, applications import Starlette. This imports Starlette, the lightweight ASGI framework that handles HTTP routing and request response cycles. It serves as the foundation for building the nested application structure in this example. From Starlette, routing import mount. Imports mount from Starlette's routing system. This enables URL path nesting by mounting entire applications at specific path prefixes, which is exactly what we need for the layered outer and inner route structure. Hash create your FastMCP server. MCP equals FastMCP, my server. Instantiates the core FastMCP server with the identifier myServer. This is your central hub for registering AI-callable tools and managing their execution context. The server name helps with logging and debugging across distributed systems. Hash create the ASGI app. MCP app equals MCP. HTTP app, path equals /MCP. This converts the FastMCP server into an ASGI-compatible application at the /MCP path. ASGI is the standard interface for Python async web servers, enabling integration with frameworks like Starlette, FastMCP, or Unicorn. Hash create nested application structure. Inner app equals Starlette, routes equals mount, /inner, app equals MCP app. This creates a nested ASGI application structure by mounting the FastMCP HTTP app at inner. The pattern enables URL path segmentation, letting you host multiple services under distinct path prefixes while maintaining clean routing isolation. App equals Starlette. This instantiates the root Starlette application, the top-level ASGI entry point. The nested mount structure creates a clean URL hierarchy with /outer/inner/MCP as the final FastMCP endpoint path. The lifespan parameter ensures shared resources initialize once at startup, not per request. Routes equals mount, /outer, app equals inner app. This mounts the inner application at the outer path, creating a nested routing structure. The pattern enables hierarchical URL prefixes, so all routes in inner app become accessible under outer inner, maintaining clean separation between application layers. Lifespan equals MCP app, lifespan. This implements the ASGI lifespan pattern, ensuring FastMCP's startup and shutdown handlers run exactly once, not per request. Critical for initializing shared resources like database connections or AI model instances, while guaranteeing proper cleanup on server termination. The pattern mirrors FastMCP's lifespan approach, where you define lifespan equals my lifespan to hook into server lifecycle events. Closing parenthesis terminates the Starlette application configuration. This finalizes the nested root structure we built, with outer containing inner, which mounts the MCP app at /MCP, creating the complete URL path hierarchy. Nested ASGI mounting. FastMCP's path composition lets you build hierarchical APIs where each mount point becomes a namespace for the next layer. The lifespan parameter must propagate from the innermost MCP app to the outermost Starlette instance or session management will silently fail. This pattern enables clean separation between API versions, microservices, or functional domains while maintaining a single deployment unit.
The path that grows longer becomes more precise. Yet the server that serves all paths remains perfectly still.